some cases, you'd like to be able to work with this kind of cumulative data or the total number of cases and so on and so forth in SPSS. But SPSS generally likes to have the data in its original form. So we have for each individual, instead of a cumulative 2,047 cases in Guinea, it prefers to have the data listed for each of the 2,047 cases, whether they lived or not died in SPSS. But very frequently we have data described cumulatively in tables, but we still want to be able to work with it in SPSS. So for instance, if I were to tabulate this data in Excel, I might say, okay, in the rows, I might want the particular country that I'm working with. And I might want to analyze, well, how many cases did we have in that country, and how many people lived and died? So I might say, okay, this column might be the outcome. Did they die or did they live? And this might be the total number of cases in that country. Okay, so let's compare Guinea to, say, Liberia. They happen to be right next to each other in the columns. And let's see, total number of cases in Guinea was 2,047. Total number of cases in Liberia was 7,082. Okay, and of those, let's see what the mortality rate happened to be. The mortality rate in Guinea, let's see, we had 1,214 deaths. In Guinea, we had, let's see, in Liberia, we had 2,963. 2,963. Okay, how many people lived? Well, it's going to be the difference between the total number of cases minus the number of people that died. Okay, I'm making some assumptions here. The data is a little bit inconsistent, and we don't know whether they lost track of cases, so on and so forth. A lot of other stuff might have gone on, but for our purposes, that's what I'm going to assume, that whoever didn't die was a case that we know was that survived. Okay, so in this column is going to be 7,082 minus the 2,963 people that died. So our 2x2 table is basically this section right here. The exposure was whether or not whether you lived in Guinea or whether you lived in Liberia, and the outcome was whether you died or whether you lived. In other words, mortality. So the mortality rate, or the risk of dying in Guinea, is going to be equal to 1,214 divided by 2,047. The same thing, the mortality or risk of dying in Liberia, is going to be equal to 2,963 divided by, out of 7,000 cases, is going to be a bit lower. The rate of mortality in Liberia due to Ebola seems to be a bit lower than it is in Guinea. Our relative risk is going to be 1,214 over 2047, 2,963 over 7082, or in other words, same thing as 0.549 divided by 0.41. Okay, and there we go, 1.47 times as likely to die in Guinea as you are in Liberia. If we're going to do the same thing with odds, well, the odds are going to be 1,214 divided by 83 for Guinea, and they're going to be 2963 divided by 4119 for Liberia. And of course, the odd ratio is going to be equal to 0.147 divided by 0.719. Or, in other words, 1,214 divided by 833 divided by 2963 divided by 4119. This fraction divided by this fraction. And that's going to be our odds ratio. And of course, we'd like to calculate confidence intervals for the relative risk and for the odds ratio. Okay, so that we can tell whether or not this is a significant outcome. In other words, are we sure, we're 95% certain that this is really different than 1, which would be the odds ratio if there's no difference in the mortality in these two countries, or are they indeed statistically significantly different? Okay, so another way that you might take a look at this is to compare Guinea to all the other countries. Okay, in order to do that, I have to add up all the other case rates, which is the top row here, and all the other number of deaths and so on and so forth, and use that for this part of the table instead of the two numbers for the specific table. I'll leave that for you to do that calculation. This, of course, would be 1214 over 833, and the total would be the total number of cases for these countries, and the total number of cases would be total number of cases for all of these countries, and the number of people that died would be the total mortality, total number of deaths for all the countries other than Guinea. And you could do this for each individual country if you wanted to, or only selected countries if you wanted to. Now, problem now is, how do I get this interesting data into this table, this 833, 1214, 833? How do I get that into SPSS, which would prefer, let's see, the total number of cases here that we're dealing with is going to be the sum of these two numbers. How do I get all of that data into SPSS? Okay, so let's take a look at how we might do that. And that's done by using a function called weighting, weighting, WEIGHTED into SPS in SPSS. So I'm going to pause here, and I'm going to pick it up in just a moment in this second video so that we can kind of separate these two things a little bit more easily.